The last concept from this section is coming up with a reference triangle that accurately depicts which reference triangle we want. And what I mean by that is if I look at example number 4 here, the cosine of theta equals -4/5. If I don't have this back piece right here and I say find the 6 trig functions given the cosine of theta is -4/5, how do I know if I'm dealing with something in the second quadrant or the third quadrant? Because cosine is negative in both second and third quadrants. So which reference triangle do I use? And that's where we're going to have a constraint. The first part right here is your problem. The second part is going to be the constraint. And we'll see the constraint written in one of two ways. It's either going to be that theta lies in a specific quadrant, which is going to tell us exactly where our value is going to be drawn at. Or the other way we can see a constraint is have a relationship with another trig ratio. Maybe cotangent would be greater than 0 or secant is less than 0. You're trying to figure out some value that would give me a hint of where my other piece should be drawn in. So right here, cosine is -4/5, which means that my angle has to be drawn in quadrant 2 or quadrant 3. Those are my two options. My constraint then is going to narrow down my two options to one of those two. Here I say theta lies in quadrant 3. So I'm going to draw my reference triangle in quadrant 3, since that makes both pieces true. The next piece I see is that cosine is equal to -4/5. The cosine is the adjacent over the hypotenuse. So if I'm going to draw the adjacent and the hypotenuse here, the adjacent side is 4, the hypotenuse is 5. Now, how do I know which one is going to be negative? And the answer is, if I look at this, I'm going left on my triangle. So this is going to be -4. The other piece is that the hypotenuse is always a positive distance. So if you're ever confused on which one is going to be negative or positive, the hypotenuse is always positive. I then need to find the remaining side of this triangle. This being a right triangle here and the longest side being 5 is a 3, 4, 5 triangle. And being in the third quadrant, both x's and y's are negative. If you didn't know 3, 4, 5 just by looking at it, you could use Pythagorean theorem and solve out for the first side. Now that we know the constraint and we have our entire reference triangle drawn, I can come up with my 6 trig functions. The sine of theta is going to be the adjacent over the hypotenuse, which is going to be -3/5. Cosine of theta, we're already given in the original, -4/5. And the tangent of theta is opposite over the adjacent, which is going to be a +3/4. Two negatives make a positive. And then finally, my reciprocal functions are flipping the numerator and denominator. Secant is the reciprocal of sine, which is -5/3. Excuse me, cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, which is -5/4. And cotangent is the reciprocal of tangent, which is going to be a +4/3.